Hello, hi student. This is Priya, your maths tutor, and once again, I welcome you all on my channel Vidya. So, today we are going to start chapter 9, circles of the class 9 mathematics. So, let's get started. And before we start, let's see what are the topics that we need to cover in this chapter. So, the topics are, first of all, we'll recall what a circle means and the term related to circles. We'll revise all the terms related to circle. Then the topics related to this chapters are, this chapter is, the first one is angle subtended by the chord at a point, perpendicular from the center to a chord, circle through three given points, equal chords and their distances from the center, angle subtended by an arc of a circle, and the last topic is a cyclic quadrilateral. So let's revise the terms related to circle. So, what a circle means. First of all, the basic point is to understand what a circle means. So, circle is a locus of such points which are at equidistant from a fixed point in a plane. So, if we'll take a fixed point, then circle is a locus or collection of those points whose distance from a fixed point is same. That is, if I'll draw like this, and this is a center, so taking a distance at any point on the circle from this fixed point will be same. And this fixed point is known as center, and the distance which is same throughout a circle from the center, it is known as radius of the circle. Or okay, so circle is a collection of those points in a plane that are at constant distance from a fixed point. Constant means same distance. That is, from a fixed point, distance of all the points on the circle is same. Okay, and that fixed point is known as center, and the equal distance is known as the radius of the circle. All right. Now, the next is what a concentric circle is. Concentric. From the word, see, con means same, centric means center. So, circles having the same radius, same center, but different radius is called concentric circles. Suppose I'm taking a center, right? I'm drawing a circle with respect to this center. Now I'm drawing a circle with respect to the same center, but with the different radius. Again, if I'll draw another circle with respect to the same circle, but with different radius. So we can draw different circles with the same radius, with the same center, but a different radius. And such circles are known as concentric circles. So concentric circles means circles having the same center, but different radii are known as concentric circle, right? Now, the next we have is arc. What an arc means. The continuous piece of a circle is called arc of a circle. So if we'll draw a circle, then continuous part of a circle. If I'll take this part, this is called the arc of a circle. If we'll take any continuous part, this is called the arc of a circle. Taking here, this is called the arc of a circle. This is arc of a circle. Okay. Now, what a chord means. So, chord, a line segment joining any two points on a circle is called chord. So, if we'll join any 2 points on circle, suppose we'll take one point and the other point I'm taking this. So, if I will join these 2 points, then this line segment, which is obtained by joining any 2 points on the circle, this line segment is known as chord. Okay. And if we'll join, suppose if I'm taking a circle such that okay, let me take a circle. So suppose I'm taking this circle. Okay. Now, if I'll join the 2 points on the circle such that these 2 points will pass through the center. Okay, these are the points, and line joining these 2 points will pass through the center. Then this chord is known as diameter. Okay, and diameter of the circle is the longest chord. Okay, see, if I'll join any 2 points except which are not passing through the center, and line joining any 2 points which are not passing through the center, suppose like this, taking one more, this. If I'll join like this, so among all the chords I have drawn, you can see the one which is the longest is this one. That is the one which is passing to the center. The chord which is passing to the center is the longest chord, and that chord is known as a diameter. Okay. And the diameter of the circle divides it into 2 equal parts. So this is a diameter, and this diameter dividing the circle into 2 equal parts, which are the 2 equal arcs. So this arc, if I'll draw one arc on the one part of diameter, this one, and another arc on the other side of diameter, these are the equal arcs, and these equal arcs joining with the diameter is known as semicircle. So half of the circle, this is a semicircle. All right, wonderful. Now we have the theorem, which is a very important theorem. So let's revise the first theorem, which is 9.1. So the theorem is 2 equal chords of a circle subtends equal angles at the center of the circle. That is, if we'll take any 2 chords which are equal, right? Taking any 2 chords which are equal, those 2 chords will subtend equal angle at the center. What that means, if I will take a chord, suppose we have taken AB and PQ. 2 equal chords are AB and PQ. Now, if I will join the chords through the center, we'll get these 2 triangles. Now, the angles subtended by the chords at the center, that is angle AOB and angle POQ. We need to prove that these 2 angles will also be equal. Okay, so these 2 angles will also be equal. That is, if we are taking any 2 chords which are equal, then angles subtended by those 2 chords are also equal. We need to prove this part. So let's prove. So herein we have 2 triangles, triangle AOB and triangle POQ, right? Now, first of all, we have given that this part AB is equals to PQ as both are the chords, and we have taken 2 equal chords only. So both are equal. So AB is equals to PQ, the first equation, as they are equal chords. Next, AO, that is the one side of one triangle, is equals to OP, the corresponding side of other triangle, right? Now, why they are equal? Because they are radii. So OA is equals to OB, OP is equals to OQ, and all these are also equal as all are the radii. Now, using 1, 2, and 3, we can say that these 2 triangles are congruent to each other, right? Because all the 3 sides of one triangle is congruent to all the 3 sides of the corresponding other triangle, same to other triangle, right? So that is triangle AOB is congruent to triangle POQ by side congruency. Yes. Now, we know that when the 2 triangles are congruent, then their congruent parts are also same. So that is corresponding parts of the congruent triangle. These are the corresponding parts. One angle, these are also the corresponding parts, and these are also the corresponding parts. So we can prove them as well equal, but herein we need just to prove this part equal. So we'll take only this part. So that is angle AOB is equals to angle POQ, and this is what we have to prove. Hence proved. I hope it is clear to everyone. Wonderful. So let's revise it again. So first of all, what is given in this theorem? So we have given the two equal chords of a circle subtend equal angle at the center of a circle. So we'll take any two chords which are equal to each other. Okay. We'll take any two chords which are equal to each other. Suppose we have taken here AB and PQ, right? Which are equal. So we have taken AB and PQ which are equal. Now, AB is equals to PQ, we have marked it as first equation. Now the second one we have OA is equals to OB, OP is equals to OQ. All these are equal. So herein we will write like this. OA is equals to OP, we'll write OP here, and OB is equals to OQ. All right. So as these are the radius, so they are equal. Now, using the equation 1, 2, and 3, we can say that the two triangles, triangle AOB and triangle POQ, are the congruent to each other using side, side, side congruency, right? And we know that when the two triangles are congruent, their corresponding parts are equal. So these two triangles are congruent. So that is their corresponding part, that is angle AOB is equals to angle POQ. And this is what we have to prove, right? I hope it is clear to everyone. Wonderful. So we have completed till the theorem 9.1. So further we'll continue this next topics in the next sessions. So for that, stay tuned. Bye-bye. Have a nice day.